It's day 3 in our 500,000 subscriber celebration week, and we continue with another well-known flat earther, Kyle Adams. He makes videos about flat earth science, and today he wants to tell us about something called the Midnight Zone. Hello all and welcome along to this Wednesday edition of Flat Earth Friday with me, Simon Dan. Thank you very much for joining me. Just a quick announcement before we begin. I have given the channel memberships a full revamp. So if you want to have a look at those, all you need to do is click the join button under this video. There are things on there that only members can get, so check it out when you get the chance. Right, on with today's video, and one Kyle Adams. He's got a video called Midnight Zones. And honestly, it is one of the most classic examples of flat earthers making up gumph to suit their own model. You've been warned. Take it away, Kyle.
Way down at the bottom of the ocean lies a very dark abyss, commonly referred to as the Midnight Zone. That is a really interesting name choice, isn't it? Well, it doesn't just stop there. If we look at the zone above it, it's called the Twilight Zone. And the zone above that, it's called the Sunlight Zone.
I think it's quite self-explanatory, that one, Kyle, thank you. It is of course all named so because of the amount of light reaching each different zone.
That sounds just like the zones of the atmosphere.
Well, not really. If you'd asked me to start talking about the zones of the atmosphere, I'd be talking about the stratosphere, the mesosphere, the troposphere, etc., etc.
That is because the same concept is involved in both instances. The truth has seriously been hidden in plain sight.
Okay, it is a similar concept in that we're talking about the scattering of light, but not at all the same concept when we're talking about the absence of light in each scenario.
Concerning the ocean, water and other matter in the water limits how far you can see. We refer to this as opacity, or the opaqueness of the water's ability to prevent light from passing through it. According to the American Museum of Natural History, the midnight zone in the ocean is dark because of the opacity of the water. They say the ocean is very, very deep. Light can only penetrate so far below the surface of the ocean. As the light energy travels through the water, the molecules in the water scatter and absorb it. At great depths, light is so scattered that there is nothing left to detect.
Okay, great. We know why the deep ocean is dark. Perfect. Now, listen how he's going to use that fact to distort other facts.
Likewise, we know that there's water in the Earth's atmosphere. It's just less dense than the water in the ocean.
It is also in a different state. Water in the ocean is a liquid. Water in the atmosphere is a gas. Liquid water is almost 2,000 times more dense than water vapor.
And the water in the air similarly filters light.
It's partly responsible for absorbing light because it's in the air, but I'm not so sure about filtration.
But being less dense, it requires more room. In the ocean, the sunlight zone is said to extend from the surface to a depth of 656 feet deep. 1 mile is 5,280 feet. Daylight on Earth is said to extend about 12,450.5 miles.
So Kyle is just half the circumference of the Earth, if you're wondering where he got that figure from.
But that depends on the season. My point is, that is a lot more room.
What is he even blithering on about? More room for what?
Now, concerning the atmosphere, I have mentioned atmospheric opacity before, and described it as one of the 3 major reasons why night exists on the flat Earth.
Well, that is absolute nonsense because the atmosphere is 0% opaque for the visible light spectrum.
To that, a member of our debate board asked the question, if the atmosphere is opaque, how do we see through it?
Because it is not opaque. Dear oh dear, this is absolute village, isn't it?
Well, it is the same thing as what we see going on here in the ocean. We can see through it a little ways, but the farther and farther you look, the more and more opaque the water becomes. Another common example I like to use is sheep protectors. I can see through one just fine, but as I stack more and more on top of each other, the more and more opaque they become. In this instance, one sheet protector represents a certain amount of distance in the atmosphere.
Sheet protectors? I mean, come on. Seeing things on the horizon can sometimes be more difficult. The key word here is can. Sometimes humidity and turbulence makes things difficult to see near the horizon. But sometimes it doesn't, and you can see perfectly. In your sheet protector analogy, you will never be able to see perfectly.
This is why we can't just pull out a telescope and see Europe from America.
No, that would be because Europe is hidden behind a massive planet.
Now, a frequent question I hear concerning this is, well, the stars are way farther away than Europe is, so why can we see the stars on the horizon, but not see Europe?
Yep, that's an easy one. The stars are in the sky and not on the same planet as you, thousands of miles away on a different side of it.
To that, I ask that you please remember that we live in an atmospheric gradient, which means the atmosphere is less dense at higher altitudes, which means light can travel farther at higher altitudes.
But your sheet analogy must be the same for viewing up as viewing across. You can't just pick and choose when the atmosphere is going to be opaque and when it's not.
Additionally, please remember our three factors that cause night on the flat Earth. Night isn't just caused by atmospheric opacity. We have this other thing over here called refraction.
Anytime light slows down, coming at an angle into a medium, the path of light bends. The physics term for that is refraction.
Oh.
It refracts.
Thank you, Neil. We demonstrated that in our fish tank laser experiment, when we created a gradient in the water and caused the light to get bent downward. This in turn caused objects to appear lower than they actually were.
An actual experiment from Kyle here. Nice. Of course, he's absolutely bereft at how that hinders the flat Earth model rather than helps it, but carry on.
So when the light from the stars get refracted downward, it causes them to appear lower than they actually are.
The angle of refraction for a star at an apparent altitude of 45 degrees is less than 1 arc minute. That is 0.02 degrees. So a hell of a lot less than that angle on your diagram.
This is why we can't see Europe from America. But we can see the stars above and beyond Europe. Now, if you were to listen to Neil Tyson for a little while longer, he will claim that the downward refraction of the light will cause the source of the light to appear higher than it actually is.
At certain angles, yes. If the star is directly above you at your zenith, then there will be no refraction.
Not lower. And there are demonstrations that can show us that this is possible. We addressed this in our fish tank laser experiment, part 2 and part 3, and further proved that in this instance, the downward refraction will cause the light source to appear lower than it really is. If you haven't seen it already, it is very much worth checking out. Here are some links to those videos. We've also got them included in this video's description. The important thing to remember here is that night isn't caused by just one thing taking place.
Actually, it is. The rotation of the Earth. Isn't that a lot simpler than trying to say that night is caused by refraction, atmospheric opacity, of which there is none, and the divergence of light? I would say so. Talk about trying to shove a hexagonal shaped block into a triangular shaped hole. Well, what do we all think of Kyle's woeful video there? Let me know in the comments your personal highlight. But for now, we're all done and dusted for this Wednesday edition of Flat Earth Friday. Thank you so much for watching, it's truly appreciated. Please do consider subscribing to the channel. We're going for the 1 million now. And of course, if you really like this one, then give it a thumbs up. And if you really, really, really liked it, then you can share it as well. I've been Simon Dan. Have yourselves a great day, and I'll see you all tomorrow for the next celebratory video where we take a look at Mr. Nile Challenge himself, Anthony Bear. See you then.